Let us start the lecture. In this lecture, we are going to discuss about the expression for velocity, radius, energy, and wave number of an electron when it is revolving in a circular orbit around the nucleus. Yes or no? As we know, inside the atom, we have two things. One is our nucleus and another is our electron. Yes or no? Here this is our nucleus and this is the orbit. Actually, we can say for in both certain model, this is a stationary orbit. After then, one electron is there, which is a revolve around this orbit. Sorry, around the nucleus along this orbit. Yes or no? Then just like this. As we know, inside the nucleus we have z number of protons, and charge of each proton is 1.6 into 10 power minus 19 coulomb. That is plus 1.6 into 10 power minus 19 coulomb. So here you can write charge of nucleus is our plus Jd. Okay, and charge of electron, as you know, minus E, minus 1.6 into 10 power minus 19 coulomb. Yes or no? After then, the radius of orbit is our r, in which electron revolve, and then velocity of electron let be v. Yes or no? After then, as we know, if two charged particles are there, and then there must be electrostatic force of attraction. Here, as we know, nucleus is our positively charged and electron is our negatively charged. So here electrostatic force of attraction will be arises, or you can also say Coulombic force of attraction. And from Coulomb's law, we know the force is our 1 by 4 pi epsilon naught q1 q2 by r square. Yes or no? Fe, F for force, E for electrostatic force of attraction. Yes or no? And this is 1 by 4 pi epsilon naught q1 q2 by r square. As we know, q1 and q2 are the magnitude of two charges. So here in place of q1 we can write plus Jd, and in place of q2 we can write plus E. Yes or no? Then what we got here? 1 by 4 pi epsilon naught Jd square by r square. Yes or no? After then, as electrons revolve along a circular path, so there must be centripetal force, and the expression for centripetal force we know mv square by r. To revolve in a fixed circular orbit, actually here the centripetal force is given by the electrostatic force of attraction, or you can also say to revolve in a fixed circular orbit, electrostatic force of attraction and centripetal force must be equal. In place of Fc we can write mv square by r. In place of Fe we can write 1 by 4 pi epsilon naught Jd square by r square, which we already get. After solving this, we can get mv square is equal to 1 by 4 pi epsilon naught Jd square by r. Let this be equation 1. Remember this one. Okay. After then, from Bohr's postulate we have L, angular momentum. Angular momentum is our integral multiple of h by 2 pi. Yes or no? Where n is our principal quantum number, or you can say orbit number actually. Yes, so, and n starts from 1. For first orbit n equal to 1, for second orbit n equal to 2. Yes or no? And then h is our Planck's constant. Yes or no? And m is our mass of electron, v is our velocity of electron, r equal to radius of circular path. And from this we can get mv actually, which is equal to nh by 2 pi r. Yes or no? Let this be equation 2. Then we have to divide equation 1 by equation 2, so that we can get velocity. So what we got is just write down equation 1 and then equation 2. mv square by mv equal to 1 by 4 pi epsilon naught Jd square by r square nh by 2 pi r. Cancel out. V square by v is equal to v. Yes or no? Then we got this. After then, by simplifying, we can get v equal to 1 by 4 pi epsilon naught 2 pi Jd square upon nh. This is general form of velocity. Yes or no? Here we have to find the velocity of electron in the first orbit of hydrogen. So what I have to write? As you know, for hydrogen z is equal to 1, and for first orbit n equal to 1. Yes or no? So velocity of electron in the first orbit of hydrogen atom becomes, as you know, the value of 1 by 4 pi epsilon naught is 9 into 10 power 9. The value of pi is 3.141. Then after then the value of E, charge of electron, is 1.6 into 10 power minus 19 coulomb. After then h equal to 6.626 into 10 power minus 34 joule second. Yes or no? And by putting these values we can get the velocity of electron in the first orbit of hydrogen atom is 2.1 into 10 power 6 meter second per minus 1, or you can also write C by 137. Then what is C? C is our velocity of light in vacuum. That is, as we know, C equal to 3 into 10 power 8 meter per second. Yes or no? In general, we can write our Vn is equal to V hydrogen, actually fast orbit, into Z upon N. Then also you can write for a constant Z. Constant Z means for a fixed atom. If you change the number of orbit, then you can write Vn proportional to 1 by n. Vn proportional to 1 by n, or you can write V1 by V2 is equal to N2 upon N1. Yes or no? Then if we take the orbit, the same orbit for different atom, that is n constant and different Z, so that you can get Vn, or you can write V1 by V2 equal to Z1 upon Z2. Yes or no? As here you can see, velocity is inversely proportional to n. That means if number of orbit increases, orbit number increases, then velocity decreases. That it says closer the orbit, more is the velocity. Yes or no? This is all about the velocity. After that, we have to find the expression for radius. Then how can we get the radius? Actually, from velocity we get 1 by 4 pi epsilon 2 pi z square by nh. Yes or no? And we have to put this expression for velocity in equation 2, which we get actually, that is our mv equal to nh by 2 pi r. Yes or no? From equation 2 we have mv equal to nh by 2 pi r. So from this we can write r is equal to nh by 2 pi mv. In place of v we can write 1 by 4 pi epsilon naught 2 pi z square by nh. So this becomes, by solving this we can get, remember this one, r is equal to epsilon naught n square s square by pi z m square. This is the expression for radius. Remember this one. And as you know, for hydrogen z is equal to 1 and n equal to also 1. So the radius of fast orbit of hydrogen atom, or you can say Bohr radius also. Yes or no? So what you got here, just write down, r is equal to epsilon naught. If for any orbit of hydrogen, we can write epsilon naught n square s square by pi m e square. For fast orbit or Bohr radius, we can write n equal to 1. So this becomes epsilon naught h square by pi m e square, and this becomes 0.53 Armstrong. 1 Armstrong is a 10 power minus 10 meter. In general, r can be written as r naught n square upon z. R naught is a 0.53 Armstrong. Yes or no? Then see, r is proportional to n square if z is constant. So for fixed atom, we can write r proportional to n square, r1 upon r2. Yes or no? After then, if you take different atom but same orbit, so that we can get here n equal to constant. Hence, r proportional to 1 by z. Yes or no? Here you can see, if we increase the atomic number, then our radius of orbit decreases. Because if you increase the atomic number, then number of proton inside the nucleus increases, so that they attract more tightly. Hence the radius decreases. Yes or no? This is all about the radius actually. After then, we have to find the expression for energy. Electron revolve in a orbit, so here we have to calculate two energies. One is our potential energy and another is our kinetic energy. So the total energy is our sum of potential and kinetic energy. First of all, we have to find the kinetic energy. The expression for kinetic energy is our half mv square. From equation 1 we have mv square is equal to 1 by 4 pi epsilon naught z square by r. Just remember this one. So here you can write, this is the expression for kinetic energy. After then, we have to write the expression for potential energy. Here we have to write the electrostatic potential energy, and the formula for electrostatic potential energy is 1 by 4 pi epsilon naught q1 q2 upon r. Here we don't have to take the magnitude of the charges. Okay, so in place of q1 we can write plus jd, and in place of q2 you have to write minus e, so that we got the kinetic energy expression and potential energy expression. So finally we have to write the total energy expression. Total energy is our kinetic energy plus potential energy. Clearly from these three equations we can get if total energy is given, then we can find kinetic energy. Just this one. Kinetic energy can be written as negative of total energy. Yes or no? Here we have 1 by 2 1 by 4 pi epsilon jd square upon r. Here also 1 by 2 1 by 4 pi epsilon jd square upon r. Only negative sign is there. So we can write kinetic energy equal to negative of total energy. Similarly, we can write potential energy 2 of total energy. If total energy of an electron in a fixed orbit is given, then we can find the kinetic and potential energy. We have to put the expression for r here. As you know, expression for r is our epsilon naught n square s square upon pi z m e square. So by putting this, we can get the expression for energy of an electron in a fixed orbit. Yes or no? Then just find out that one. This is our expression for energy. Yes or no? So just multiply 2 pi and divide 2 pi to get a simple general equation. Here you can get, here I just write in place of total energy I can write E is the total energy, E n for nth orbit. So this becomes negative of 1 by 4 pi epsilon naught whole square 2 pi square z square m e power 4 upon n square s square. And first of all we have to find the energy of first orbit of hydrogen atom, or for hydrogen atom. Yes or no? For hydrogen atom z is equal to 1. Yes or no? For first orbit n equal to 1, later on we can put that. So first of all we have to put z equal to 1. So what we got here, this is the expression for the energy of hydrogen atom. But then if you put n equal to 1, that is the energy of electron in the first orbit of hydrogen atom, then what we got here, and this becomes, remember this one, the energy of electron in the first orbit of hydrogen atom is minus 13.6 eV. This is the energy of electron in the first orbit of hydrogen atom. So in general you can write En can be written as E1 into z square upon n square for fixed atom, or we can write z constant, En proportional to 1 by n square. And for fixed orbit, if different atom is taken, so that n is our constant and z different. So here you can write En proportional to z square, or U1 by E2 equal z square z2 square. So actually just remember some energy of some orbits of hydrogen atom. Negative symbol indicates electron is bound to the system or bound to the nucleus. In general you can write actually n is our minus 13.6 upon n square eV. This is all about the energy. After then we have to find the expression for wave number. Yes or no? E1 is our energy of electron corresponding to the orbit n1, and E2 is our energy of electron corresponding to the orbit n2. So here in E1 we can write n1, and in E2 we can write n2. As you know, E2 minus E1 equal to h nu. So just write down that one. Now see here. Here we have to replace nu by c by lambda. As you know, c equal to nu lambda. Yes or no? So in place of nu you can write c by lambda. After then in place of E2 we have to write the expression for E2, and in place of E1 we have to write the expression for E1. So from that we can get common 1 by 4 pi epsilon naught whole square 2 pi square z square m e power 4 upon s square. So what we got here, 1 by n1 square minus 1 by n2 square. As E1 is here, so negative of E1 becomes positive, so n1 becomes n1 comes to first, and then after m2. Yes or no? So by solving this we can get 1 by lambda is our rz square 1 by n1 square minus 1 by n2 square. Z square is also there. So what is r actually? Actually here r is our Rydberg constant, which is 1 by 4 pi epsilon naught whole square 2 pi square m e power 4 by cs cube, and the value of Rydberg constant is 1.097 into 10 power 7 meter inverse. Yes or no? And for hydrogen, as we know, z equal to 1, so we can write the expression for wave number of electron in hydrogen atom is our 1 by lambda equal to r in bracket 1 by n1 square minus 1 by n2 square. Okay, n2 is a higher orbit, n1 is a lower orbit. This is all about the lecture.